Hi, welcome to another edition of Matt's Garage, but actually we're kind of in the kitchen right now because it's a little cold in my garage because it's in the 40s here in the Pacific Northwest. What we're going to do today is we're not going to talk about motorcycles, we're going to talk about furnaces. You want to know how your furnace works. Okay, how does my furnace work? What happens? How does the heat get from one thing to another? What happens there? Well, first let's talk about the different parts of a furnace and what a furnace does. A furnace converts gas, whether it's natural gas, oil, might be oil, or coal, it converts that to heat. How does it do that? How does it do that? Basically, a furnace has three different parts. It has a blower section. Let's do a side view of this. It has a blower section. Okay, that's what pulls the air in and moves it out. It has a heat exchanger. The heat exchanger can be a clamshell, or in the newer styles, it can be a bent tube. All right, and it has a gas train. And what's the gas train? All right, we'll talk about each one individually. Okay, but those three basic parts, no matter what type of furnace you have. Okay, in the old type of furnaces, we had what was called a clamshell. In that clamshell, let's make this a little bit even here. I want to make sure that I draw so that when people respond to me later, they don't say you're a terrible artist, which I already know. So this clamshell would take the heat exchanger heat. Oh man, I am really rocking this picture here. I'm telling you what, I'm really rocking it. Anyway, let me put some shading on it. Woo! Might have a few dimples in here too. But we'd have what was called a ribbon burner, and this ribbon burner would take the gas from the gas train, and our gas train would have a pipe. Oh, let me go back to my black here. Would have a pipe that comes along, and it would have some orifices that come out, and it would have an electric gas valve and maybe a pilot light. Okay. Everybody's familiar with the pilot light, right? Because that's what I always think, oh man, my pilot light went out. Okay, so the thermostat would call for heat. Say, that's what we call it. Say it has a call for heat. Thermostat has a call for heat. Oh, here we go. Now you can see that a little bit better. Thermostat has a, see, there's the ribbon burner, bottom of the clamshell, heat exchanger, gas valve. Let me see if I can get this a little bit better. Let me put it out a little bit. There we go. You can see my wooden spoons in the background there. Okay, and then the gas, once the thermostat called for heat, and the gas valve would get a 24-volt signal that says, hey, open up. And it would allow gas to come through, and it would light our pilot light. Our pilot light would light the gas on that burner, and we would get heat flowing up through here and then out our flue gas hole, okay, at the top of the clamshell. All right, so that would happen. Most of your heat, you know, about 30% of your heat or more, depending on the age of the furnace, would be going out as products of combustion. You wouldn't even be able to utilize that. The air would be blown from your blower, separate compartment down here. Okay, it would be blown from your blower across the outside of this heat exchanger. It would extract the heat. The heat would be radiating out from the side of the heat exchanger, and by convection the airflow would pick that up and then distribute it through your house. Okay, that's how the older furnaces work. That's if you have a pilot light on a furnace, more than likely that it has a clamshell type heat exchanger, and that's what's happened. Let me see if I can remember. I'll zoom in a little bit and remember to make my pictures just a little bit higher. Okay, newer furnaces. Okay, the newer furnace has a, okay, we'll be able to see it, has a bent tube heat exchanger. Okay, this is going to be really primitive. I'm going to make this so that we can see it easily. Okay, it's going to have more bends than this, but I just want you to get the picture that's going to be a bent tube, and I don't want people to call me later or put posts on there to say, hey, this is a terrible picture, because I already know that. Thanks. Okay, so we have a bent tube heat exchanger. We have what, instead of a ribbon burner like what we had before, instead of a long burner, that was called a ribbon burner like that, we now have what is called an in-shot burner. And the in-shot burner basically looks like a little Venturi. Okay, and it has the gas train, just like what we had before, has an orifice and a gas valve. Let's put the gas valve here and connect it. That's a connection to the gas valve. Okay, we still got a thermostat. Okay, the thermostat will call for heat. All right, and what happens now on this 80% of this new style furnace to make this in-shot burner work properly is at the top of this we add a chamber and we add a little fan. We have an induced draft fan. So this fan starts spinning. It starts pulling air up through here. Alright, once it makes a couple of safeties in there, it allows the gas train to open up, or excuse me, not the gas train to open up, but it allows a hot surface igniter or a spark. Normally nowadays it's a hot surface igniter. You can think of it as a glow plug. It will start glowing. It allows that to turn on. Once that turns on, okay, so the thermostat calls for heat. The hot surface, or the induced draft fan motor, comes on. It starts to pull the air through. Once it makes the safeties that are connected to it, the hot surface igniter comes on, and once it starts to glow, and it's been on for about 45 seconds, it allows a signal to be sent back to the gas valve. Remember, this is all a computerized board now, and the gas valve opens up. It allows the gas to be thrown through. Let's put a little bit of fanciness on this. I'm going to use a red marker now, and fuel comes flying through here, and it goes up. Okay, and since this is computerized now, there's a computerized module in there that tells the fan motor to come on at about anywhere between 30, 45, 90, and 180 seconds. Okay, alright, so that's how our furnace works. Alright, and we'll continue this in another one where we discuss more things about the furnace. Thank you.